This is web assigned number 36, problem number 2. A thin spherical shell of a given mass and a given diameter is filled with alcohol, and they give you the density. You then release the shell from rest on the bottom of a pool of water, and you are asked to find the acceleration of the filled shell as it rises toward the surface. So the shell will accelerate upward if the buoyant force is greater than the weight of the filled shell, and this is the case in this problem. We know that this object accelerates upward, which means it has a large buoyant force in the upward direction, and its weight, which is downward, is less than the buoyant force. So we know that this has a net force. There are two ways to find this. You can take the mass of the object times the acceleration, that's Newton's second law. And another way of expressing the net force is to find it from the free body diagram. In this case, there's a net upward force, and that would be equal to B minus the weight. So we're going to use this later in order to find our acceleration. Okay, you know this is a spherical shell, so the volume is 4/3 pi r cubed, but we're given a diameter. So we have to divide the diameter by 2 to get the radius. We plug that into our volume equation, 4/3 pi r cubed, and we get a volume of the shell. Now, the total weight will equal the weight of the alcohol plus the weight of the shell. Now, you're given the density of the alcohol in the problem. The density of alcohol is given as 806. We just found the volume, and then we have to multiply by the acceleration due to gravity. So we get a weight for the alcohol of 64.62 newtons. The weight of the shell, well, we're given the mass of the shell. So if we multiply the mass times the acceleration due to gravity, we get the weight of the unfilled shell to be 2.94. So we add these two together to get our downward weight of our filled shell. And I wanted to get the mass also because we need this for Newton's second law. We just divide by the acceleration due to gravity to get the mass. The next thing we need to do is find the buoyant force. Just remember, the buoyant force is always equal to the weight of the water displaced. When we multiply the density of the water times the volume of water displaced, we get mass. So the buoyant force is really equal to the mass times the acceleration due to gravity. So I'm finding the weight of the water by multiplying the density, which is 1,000, times the volume of the shell, which we found before because the entire shell is underwater, times the acceleration due to gravity, and our buoyant force is 80.17 newtons. So we're using the free body diagram in Newton's second law. The net force on the shell from Newton's second law is its mass times its acceleration. And from the free body diagram, we have the buoyant force minus the weight of the filled shell. So I solve for A, substitute in the numbers we found before to get an acceleration upwards of 1.83 meters per second squared. Hope this helps.